Good morning and welcome to one more session. Today we'll go through one of the topic that's part of the AIOps. It's all about how exactly within the GPU communicate the NVLink, NVSwitch, why not PCI, how exactly the CUDA, what is SM, all those things, a little bit only on related to the networking part of that one. We'll have a overlook of what different type of networking we create or different fabric we create in the data center of AI, and we'll focus only the communication between the GPUs. Okay, let's start. Okay, so what is the difference? The whole topic we'll cover is the NVLink and NVSwitch. Okay, so in a data center, we don't usually have the typical single networking concept, right? We have different key features, and there are a lot of communications happen between these computers or multiple entities. For example, the AI mostly work on GPUs, right? And the GPUs are nothing but the CUDA cores, and which is part of the SM. Okay, let's go through a little bit of that one. Okay, so AI data center use multiple separate network, one for compute, storage, in-band management, and out-band management. Okay, so this is just to isolate the traffic for the better communication, and there should not be any fault tolerance, security, stability, and no bottlenecks for that reason. They separate it. Okay, so what really in the data center we go is called as scale up, okay, scale out, and the management related things. So the key part over here, what we are going to focus is how the communication and why we have a different network, okay, just to communicate between the GPUs. Okay, and what is the limitation, not limitation, what is the scope of the NVLinks. Okay, so if you see in this particular diagram, okay, this one is one of the GPU and this one is another GPU. Both resides on one physical node. It could be a supercomputer or the super cluster based computer, but there is no external, so it's within this inter-node communication, right? It's a GPU and GPU communication within the computer. Okay, we have different things called as InfiniBand for the inter-node communication, but for this video we'll go for only the GPU communication. So if you see in the diagram, you are seeing on the video, you will see here it's not visible because of green screen. Okay, we have multiple this each GPU will be having multiple SMs. Okay, so what is the SM is for? Within that actually we get multiple CUDA cores. Okay, so each GPU can have multiple CUDA cores, right? And so each SM contains around 64 to 128 CUDA cores, okay, and a tensor core, okay, plus RT core. Okay, these are multiple cores, different cores that happens within that. Okay, and the GPU can contain multiple SMs. Okay, so a GPU could be having thousands of CUDA cores. Okay, and let's say another GPU which is also having 1,000 cores communication, GPUs, CUDA cores. Now if we have to communicate between them, so what really happens is the AI, when it execute, right, it do multiple things like all reduction, all gathered, reduce, subscatter, and broadcast. Okay, and to communicate this much big data, if we go through a PCI communication, the PCI communication usually have a speed limitations of around 32 to 64 GB per seconds, right? But the whole transaction need to be way faster. And if you see, to communicate between these GPU to GPU CUDA cores, GPU to GPU, okay, we have the NVLink. Okay, and the NVSwitch is another one which redirect between, let's say we have multiple GPUs, right? Let's say I have 8 GPU. So how exactly they will communicate? If I have just a link, it will be just one point to point. The switch take care between where exactly the communication happens. Okay. So if you see in this particular diagram, the bottleneck of PCIs is because it's a far low speed. Okay. That's the main reason we got introduced of NVLink. And to route the data, we have NVSwitch. Okay. And the NVLink and NVSwitch will help you to reach somewhere around 600 to 900 GB per second, which is far more than around 32 to 64 GB per second. So that's the main reason how the NVIDIA actually introduced the NVLink. The latest talks are going on where can we do NVLinks across different nodes? Technically, no. Okay, NVIDIA might be working on something, but so across one there is something similar to called as InfyBeam. Okay, in the upcoming video we'll go through that one. So NVLink will help you on communicating between different GPUs. Okay, and why we need a different GPUs? Because they have lot of the AIs when it do the experts communications, right, between different layers. They need multiple work and they need to communicate with each other. Because of each other communication, if they go through the PCIe bus, which is far slower, this is where the NVLinks come up. Okay, so we can read the further why exactly it is the direct access. Another good part is you don't have to copy the data to the CPUs, right, through the PCI link, and you can direct access direct data copy between GPU to GPU, and which works because of the NVLink. Okay, this is similar. You can go through further in this documentation. Okay, the relationship between the streaming multiprocessor SM and why between that we have different CODA cores are there. What are the speed limitations? What are the, once you understand the speed limitations, that's the main reason the NVIDIA introduced the NVSwitch. Okay, so this is one of the quick table between the NVLink, okay, rather than not PCI based one. Okay, so what is the difference between NVLink and NVSwitch? Okay, so consider in the analogy wise, think of NVLink is for the highway one-to-one mapping, but NVSwitch, which is which nothing but a silicon chip that stay and that will help you to redirect your network traffic, right, the functions. Okay, NVSwitch is a dedicated silicon chip ASIC that act as a central crossbar switch for NVLink connection. Okay, and think about the analogy is NVSwitch as a massive highway interchange that allows cars from any center ramp to exit at any other ramp. Okay, so think about the data between the GPUs, how exactly it communicate or identify between is NVSwitch, and the communication between GPUs to the GPUs are NVLink. And the reason behind NVLink is it is far more quicker, no CPU introduction in between, and no limitations on PCIe bus. Okay, hope this quick understanding of NVLink and NVSwitch will help you on further AIOps related. We'll go through other details like InfyBeam and rest of the fabric that we use for the data communication, and later on we dive in the rest of these different things related to AIOps. Thank you.